Next, we are going to discuss how to find distance in motion in a plane, that is motion in two dimension. In the previous discussion, we have discussed how to find displacement. Now we are discussing how to find distance. So by definition of distance, it is the actual length of path followed. So to find distance, we should know the path followed. The path followed means where the particle is going, how the particle is going. Is it taking right turn, it is taking left turn, or is it moving along a curve? That curve can be circular, that curve can be parabolic. So some well-defined paths are, it can be straight line path, straight line path. It can be circular path. It can be parabolic path. These are some well-defined path. So example of circular motion, we have the particle follows circular path, and when football is thrown in air under gravity, so that type of path is parabolic. And if the ball is thrown vertically upward, so the path followed will be straight line. How to find the length of path? So let's take one example of straight line, then we will do one example from circular path, then we will talk about parabolic path. How to find distance in these type of motion in a plane. Suppose the particle is going 1 meter right side and then taking U-turn 2 meter left side. So the path is a straight line, but it is a U-turn. So how much it has traveled right side, how much it has traveled left side. Separately we have to find. So distance will be 1 plus 2. If particle is going 1 meter right side, then 2 meter along upward, or we can say 1 meter along x direction and 2 meter along y direction, or we can say 1 meter along east direction and 2 meter along north direction along a straight line. So this is known as 90-degree left turn. 90-degree left turn. The particle was going along east, then it has taken 90-degree left turn and going 2 meter. So in this case also distance is 1 plus 2, that is 3. And of course displacement also we can find. So in this example the displacement is, now for displacement we have to consider direction. So you will say 1 minus 2. So first displacement is 1, second displacement is minus 2. So it will be minus 1. Net displacement is minus 1. In this example, the net displacement will be square root of 1 square plus 2 square. So root 5 meter. This is the net displacement. But distance is 1 plus 2. So this is the example of straight line path. Let's take example of circular path. Suppose this is the point A and the particle is going anti-clockwise. Particle is going anti-clockwise along circle. How to find distance? The distance will be length of arc. Arc means circular path. Suppose it started from A and going up to B. So from center, we will say this is the initial position vector and this is the final position vector. This is R1 vector, this is R2 vector, and the angle between these two position vectors is theta. So the length of this circular path is the distance. So we have a direct formula for that. So angle into radius is equal to length of arc. When we multiply radius with angle in angle in radian, then it is known as length of arc. But the displacement is given by a vector whose tail is at A and whose head is at B. So this is the displacement vector. The magnitude of this displacement vector is two r sine theta by 2. The derivation of this can be done using trigonometry. So we have this triangle. If you draw perpendicular from center on this displacement, so we will get one isosceles triangle. This angle will be theta by 2 and this side will be s by 2. This point will be the midpoint of displacement vector. If we apply sine theta by 2, so we get opposite by hypotenuse, which is equal to radius. So s by 2 is equal to sine theta by 2. So s is equal to 2r sine theta by 2. So when the path followed is circular, distance is r theta and displacement is 2r sine theta by 2. Let's take one question. Find the ratio of distance and displacement if particle covers quarter circle. So if the particle is initially at A, then finally at B, the angle covered will be 90 degree. In quarter circle, the angle covered will be pi by 2 radian. So this is pi by 2 radian. So distance is equal to r theta. So r into pi by 2 and displacement will be, now we have a direct formula for displacement, which is 2r sine theta by 2. Now theta is 90 degree. So theta by 2 will be 45 degree. So this will be 2r sine 45 degree and sine 45 is 1 by root 2. So this is root 2 times r. So the ratio of distance and displacement will be distance divided by magnitude of displacement is equal to r into pi by 2 divided by root 2 times of r. So r cancel. So we get pi by 2 root 2 or pi is to 2 root 2. So this is our answer. If it is covering half circle, it it is going from A to B, covering half circle. So in this case, distance will be r theta. Now theta will be pi radian, and displacement will be 2r sine pi by 2 theta by 2. So sine pi by 2 is 1. So displacement is 2r, and using geometry also we can draw the displacement vector. This is the displacement vector whose tail is at initial position and head is at final position. So the length of this vector is equal to displacement magnitude, which is 2r. For 1/3 circle, now this is point A, this is point B. For 1/3 circle, the angle covered will be 360 by 3, which is 120 degree, or we can say 2 pi by 3 radian. So the distance covered can be calculated using the direct formula, which is r theta. So r into 2 pi by 3, and displacement is equal to 2r sine 2 pi by 3 by 2. So that is 2r sine pi by 3. That is 2r into root 3 by 2. So that is r root 3. Displacement is r root 3.